Hi, everybody. I'm going to try a Zoom recording of a lab, introducing an important concept that's kind of part waves topic and modern, and it's called polarization. So I'm going to gather data with a Bluetooth, and it's going to display on I'm going to share the screen here, and you're going to see the data, and you're going to record that in a sheet that I uploaded. So normally I would introduce you to polarization through a bunch of demonstrations, and I'll do that when we meet in class next, but let me just give you a quick little idea of what it's about. So here is a polarizer. Okay, we'll talk about what it is. It looks like just a filter, like something you'd have on sunglasses, and some are made of polarizers. And so what happens is when light passes from me through the polarizer to the camera, it gets attenuated. In other words, some of it is absorbed. And what makes polarizers really interesting, and even the displays there, is as I rotate it, you see right now you can't see me. I can't even see the screen, and I'm just rotating it, and all of a sudden I appear again. So what the point of this lab is going to be is to look at, there's a certain angle of orientation. It's not obvious on this circular disc, but we'll talk about it for the setup, where we can look at how much light gets through as a percentage of the original intensity and look for relationship. This is called Malice's law. So then we'll eventually do a tutorial which will summarize key points, but it's kind of a neat thing that we have the apparatus that we can actually measure this indirectly, or directly, I should say. So let me just try to turn a camera to show you what the setup looks like before I share screen and just look at the data. Okay, so I have this optical bench, the same thing we use for the slits. All right, I'm gonna try to finagle this. So what I have here is a laser source. Here I have a polarizer, kind of one I just showed you, where I can rotate it up here, and you really can't see that, to get different degrees of orientation of it. And then here I have a light sensor, which gives us how much intensity of the beam right there it is being received. And so we're going to look at that light intensity as a function of the angle of the polarizer. On the sheet at the very top, it kind of tries to illustrate that. So I don't have the sheet displayed here, but you'll have it in front of you. So let me share the screen for the data. Okay, so I'm going to have to walk you through this. So right now, is not on, but the units we're looking at is lux. Lux is really not even, it's a unit. It's not an SI unit, a metric unit of intensity. It's for light intensity, it's called the candela, but it doesn't matter. We're just looking for relative intensities. So since this light meter measures things in lux, we'll go with it. Now I'm going to start the meter, the light meter, okay? And we can see that it's reading something, and I just want to get my initial angle correct. So our initial angle is going to be 0 degrees, which allows maximum light intensity through. So let's round this to the nearest tenth because it's fluctuating quite a bit. So let's call the first one, our first data point, 95.2. Seems to be hovering around there. Now I'm going to rotate the polarizer 15 degrees, and I'm going to do it in 15-degree intervals all the way to 180. So I'll let you know when I've got it there. All right, so as best as I can determine, and there's a little bit of uncertainty in the angles, okay, this is when we rotate it 15 degrees. So let's call that, and again, it's fluctuating quite a bit, so maybe we call that 84.8. I'll let you make the call on that one. Okay, just go to the nearest tenth, so it's understanding that we know within plus or minus 2 tenths. So that's 15 degrees. All right, now I'm going to rotate it to 30 degrees. All right, so there is the intensity of the light received when the polarizer is oriented 30 degrees to the beam. Okay, we'll go to 45. So we're about a quarter of the way through. Now I'm going to go to 60 degrees. And we can see our intensity is getting less and less just by the orientation of it. And that should strike you as the odd thing, is what the heck is going on and why it's related to modern physics. 75 degrees is right here. Wow, we're almost out of 0. Then I'm going to go to 90-degree orientation. And there we have 90. So you can't get much less than that, but let's see what happens as we approach 180. So now I'm going to rotate it so we are at 105 degrees. Interesting. So we didn't get less. In fact, we increased again. Now 120 degrees is right here. Uh-oh. Let's make sure something didn't happen here. Seems like our something's not quite right with the reading because nothing is changing now. I don't know if it got frozen. So I'm going to stop this and I'm going to start it again. And I'm going to go back to 90. Let's see if we can get the light sensor reading. All right, so I'm going to pause this for right now and see if I can figure out what's going on technically speaking. Okay, so I got it working again. I had to switch. So let me go back to the share screen and we'll pick up at 90 degrees. Okay, so again, that's at 90 degrees. So let's go to 105. Okay, much more stable now for whatever reason. Now let's go to 120. And we see that it's on the rise, 135. 150. 165. And then a full half turn, 180 degrees. And we should be very near where we started. I don't remember where we started, but any discrepancies might be due to the fact that I'm not exactly at zero or I wasn't at 180. In fact, I'm going to rotate all the way around to zero once again, just to see for a comparison. So there was our zero, which is, I think, higher than we started. So again, I don't suggest changing it. And here is 180. So there seems to be a little bit of discrepancy. Let's see if we can get a, no. Okay, so that's the data for the data table. What you're going to do then is I'm going to ask you to plot theta versus intensity. Okay, you kind of can anticipate what it is. You can do it on that sheet I gave you, or you can do it on a graphing calculator and do a nice sketch of that. Then what you want to do is linearize that. And that's the challenge here. What trig function, because you're not going to get a linear function without putting some trig function there, will give you a straight line. And here is a hint. Normally with normal trig functions, especially sine, cosine, tangent, when you go from 0 to 180, generally you go into the negative realms when the value is going to be negative. That did not happen here at all. So that's a clue as to what you might have to do with the sine, cosine, or tangent to get a straight line. I think you can work it out from there with a little bit of trial and error, but what do you do to a trig function so that you always get a positive value? Okay, so it's a simple mathematical trick. And then try that on your graphing calculator to see if you can get a straight line and then develop an equation as per the instructions. All right, good luck with that. Email me or text me or message me with any questions.